Hi, so our goal on this unit, or this section, this is kind of a review unit, so if it's not review, that's all right, but that's kind of what this unit's going to be going over. And our goal for this unit, or this section, is that you can say, I can solve for one variable. So again, hopefully we've kind of seen this a few times, and this is starting to feel a little bit more comfortable because we've been doing this quite a bit. I know we did a lot in algebra or in geometry, and I know you did in algebra too. So I'm just going to kind of review and talk about a few things. We will go over verbal and algebraic, changing things from verbal to algebraic, because that's just something very important when we get into word problems, how we can change that, and then from algebraic to verbal. And then some of our properties, and then we'll get into solving. So we've used these properties quite a bit. So again, our end goal is that you can say, I can solve for one variable. Just going to kind of go through some of the nuances of the problems, but then this is our main goal here. So when we talk about solving, we have to have an equation. An equation, you can kind of see that word equal in there. So we want to make sure that's what we have, something equal to something. And our goal then is to figure out what that variable equals. So we have a variable in there that could be anything, but there's only going to be one variable that actually fits this solution, because now that I've set it equal to something, there's only one case that's going to fit that in linear equations. So first, writing algebraic expressions, we should kind of have an idea of what some of these words mean. So less than here we see is subtraction. So we should be thinking subtraction when we look at this one. And so for less than a number can be any variable because we haven't defined that number. So we could say x minus 7 because it's 7 less than a number. So we're taking the 7 from the number. We wouldn't want to do 7 minus x because that's saying we're taking x from the number, but we're taking 7 from the number. So this would be actually our correct form. Right, so here's another one. Write an algebraic expression to represent the verbal expression, the square of a number. So we have again some number. It is squared, so we should be able to recognize that that is squared. Is decreased by, so subtracting again, because decreased is subtraction, by the product. Product is multiplication of 5 and the number. So we could make it look like this. So whenever we're decreased by or less than, it's always subtracting from that. What are we subtracting? Right? So try this one. Pause the video if you're watching this at home. Try it and then check it. That's the only way that you can really get these, is if you're working a little bit on your own. That will help it just really cement in. 2 less than the cube of a number. Cube, you should be thinking of the power of 3. And again, we're going to make the 2 after. All right, so going the other way, we should also be able to write it the other way. What is this saying? So 6 is equal to, this can be written a few ways. 6 is equal to -5 plus a number would work. So this one you're going to have multiple answers or ways to say it. Some say is. 6 is -5 plus a number would work also. 6 is equal to -5 plus a number is what we have here. Right, so 7 times a number, because 7 times, because we should recognize when there's no sign in between. Minus 2 is 19. And again, there's multiple ways you could write it. Here's an example. 7 times the number minus 2 is 19 works the same as what we said. So again, I would pause the video, try this out, and then go back and see if you got the correct answer. Same with this one. So just some properties that we want to go over with equalities. So first of all, a number always is equal to itself. So you might have remembered this from geometry last year, but just kind of go through that. So I can always say something is equal to itself. So when you think of a reflection, that's showing yourself in the mirror, and that's the reflexive property. Everything is equal exactly to itself. Symmetric property says I can change the order if it's equal, and it doesn't matter. So I could say A is equal to B, or I could say B is equal to A. And I kind of remember this one with the it kind of looks like a butterfly. Like the butterfly is the same on both sides of the butterfly. Not this one, but so symmetric means I could flip it over and over. So I can say we use this property kind of a lot here. I could say 18 equals negative 2n plus 4, or negative 2n plus 4 equals 18, just because sometimes people like to work left to right because that's kind of the way we read. It doesn't have to be that way, but that's what we can do with that, and that's okay because it's an equality. Transitive property says that if I have three things equal, so the first is equal to the second, and the second is equal to the third, then the first has to be equal to the third. So if A is equal to B, B is equal to C, then A is also equal to C. So if 5p plus 3 equals 48, and 48 equals 7p minus 15, then this 5p has to equal the 7p. And then substitution is kind of what we do when we put things in for it. So we can simplify. Whenever you simplify, it's kind of substitution. So just kind of looking at some of these properties. This one, exactly the same thing on both sides. So remember, that's your reflexive property. Here we're flipping it, so first we said 9 is equal to x, and then the next time we said x is equal to 9, so that's symmetric. And then this one, we have, again, we're flipping it, so symmetric property. And then here we have 3 equals, so we have 3 is equal to x, x is equal to y, so y has to be equal to 3, or 3 equal to x, or 3 equal to y. So that means this would be transitive because we have those 3 equal properties in there. All right, so just to review too, we can always add something to both sides of an equation. It's going to still be equal, so you can kind of think of that weight bar with the weights on it. If this is my weights on both sides, if I add 5 to this side, I need to add 5 to this side to make them still equal, to make it still lined up. I can subtract something from both sides. I could take that off. They're still going to be equal. And I can multiply both sides. I could double those weights, and then it'd still be equal. Or I can divide and take half of them off. So we can use those properties. So here, this we need to get, we're solving for m, so since I'm solving for m, I need to move this over, so it's attached to the m with subtraction, so I want to do the opposite of that, so that now I have 0 here. And if I do that to this side, remember property, that equality, I need to do it to the other side. So then this equals 0, so all I have left of there is m plus 0, but we don't need to have that 0 there, equals 5.5. So just showing that addition property. So here I would probably rewrite that to here because of our symmetric property we can, and I want to unattach this 1/2 from t. So to unattach it, I would divide by 1/2. But remember, when you divide by A fraction is the same as multiplying by the reciprocal. So this would multiply to be 2, and this would multiply to be 2. And 2 over 2 is 1. So this just becomes 1. 1 times a thing is just t. But remember, if I do that to this side, have to do it to this side. I'll put a 1 under there. And 18 times 2 is 36, and 1 times 1 is 1. Don't probably need it that close. Right. So again, I would pause it, solve it, and hopefully that is making sense and starting to click again. If not, make sure you let me know and we can go over some questions on it. Same thing here. Let's go through a little bit more difficult multi-step. So this kind of goes from small to big because we're in Algebra 2 now. So we've kind of looked through a lot of them. But remember, if I have a number out front, I want to distribute that to both properties. Same thing here, I want to distribute that -2 to both things. So, and I'm going to rewrite it with the 53 at the end. Again, that's something that is a preference. So I would go 3 times y, which is 3y. 3 times -2 is -6. -2 times 3y is -6y. -2 times -1 is +2. And the reason I can change this to be equal on this side is because of symmetric property. Then I would combine like terms, so these y's could go together, 3y and -6y, different signs. Subtract the numbers, 6 minus 3 is 3. Keep the sign that has a bigger movement or bigger value is -3y. Not really value, but it moves you more on the number line. All right, and then -6 and +2 are the same type of numbers, so I'm going to put those together. I'm not changing the signs on these because they're staying on the same side. I'm just putting the weights together or putting the numbers together. So -6 and 2, again, different signs. So I'm going to subtract the two numbers. 6 minus 2 is 4, and keep this sign because that one has a bigger. Now I am going to solve this. So again, I want to unattach. But first I need to do this first, because when I divide, I have to divide everything by it. So I'm going to move this first by adding the opposite, because that'll give me 0 there. So -3y equals 57. And then I want to unattach this. It's attached by multiplication. Reverse of multiplication is division. Do it to one side. Have to do it to the other to keep it equal. So y equals 57 divided by -3, -19. And I can always check that by plugging it back in to make sure that I get the exact same, or it is balances. So try this one out, go through the steps, take your time, and then come back and see if you got the same answer. All right, so we're going to look a little bit about solving for variables. This one isn't on there. Remember, our main goal is that you can solve for one variable, but mostly solving equations. This is still an equation, but if I wanted to solve for L, then you can kind of think of this as like a number. These are all just represent some type of number. So if I could rewrite this, always when something looks real difficult, I kind of think of something simpler. Well, I know I'm solving for L, so let's pretend that I have 6 equals 5L. So this is going to represent 5, and this is 6, I'm saying. This is just n plus 21. So it kind of looks the same. So if I was solving this problem, I would subtract this 21 over. So I'd have 6 minus 21, which I would probably figure that out to be -15. So let's do that same thing here. Let's subtract this pi r squared over. Same thing, because it's kind of the same type of number. We just don't know what the number is. So I have s minus pi r squared, and I can't actually subtract it like I could here. but then I still have this pi r l.